All right, what's up, Algebra 1? We're back here with some more polynomials, and in this one, we're going to be adding and subtracting some actual polynomial groups here, okay? When we add and subtract polynomials, okay, we're not like adding the whole groups together. We're kind of combining the terms that are kind of within each group, okay, by either adding or subtracting, okay? And a key here with this, right? Oh, I forgot I had it up here, so there we go. But okay, so like terms. Okay, so like terms, you might have heard this word before, like combining like terms. And that's what we have to do here. We have to follow that rule of being able to only combine like terms. Okay, adding or subtracting only like terms. Now, what does that mean? So you know it's a like term because they have the same, and there's two things they have to have in common. Like terms have the same variable. Okay, so again, they either both have to be x's or both have to be y's, or just the letters have to be the same. Okay, and they have to have the same exponent as well to be able to add or subtract those. Okay, so we look at these examples down here. Okay, again, some of these examples we're going to be able to add, some of them we're not going to be able to. So like, okay, so this one says 3x squared minus 5x squared. So again, we look at that and we do our checks. Does it have the same variable? Yeah, right, the letters are the same, right? They're both x's. Okay, so they have the same variable. Do the variables have the same exponent on them? 2 and 2. Yes, they do. So this checks out, right? These are like terms, which means I can minus, right? I can do 3x squared minus 5x squared. And for these, I just subtract the two coefficients. That's what that word is called out in front, right? So 3x squared minus 5x squared would give me negative 2x squareds, okay? So the variable part doesn't change, just the number out in front changes, okay? So that's how we would subtract those two, okay? Looking at number 2, 7y plus 4x. Can I add those? Again, do your check. Same variable, 7y, 4x. No, right? Not the same variable. So it doesn't pass the check. So we cannot combine these. We can't combine these. They're not like terms, okay? So we would just like have to leave it. Like if it asked us to simplify this is like fully simplified. We can't combine those. I like to say this is like 7 oranges plus 4 apples. You can't really do anything with like you can't combine those at all. Okay, it's just kind of two different things. Number 3, 6x squared minus 9x. Can I combine those? Same variable. Yeah, right, they're both x's, so that part works. Same exponent. This has a 2 exponent. This doesn't, right? So these two we cannot combine either. We can't combine these either. They are not like terms. Even though they both have the same letter, the different exponents means I can't combine these either. Okay, so no good. Number 4, x cubed plus 7x cubed minus 4x squared. Okay, cubed is what I'm saying there. Cubed is that math word that means a 3 exponent. Okay, so just like how a 2 exponent is squared, 3 exponent is cubed. So that's what I'm saying there. But okay, can we add these? Again, we have 3 terms here, so we kind of have to think about all these. So same variable, all 3 of them have x's. So good, it fits that exponent. These two have the same exponent. This one doesn't. Okay, so that means that I'm going to be able to add these two together. I can add these two, but this one cannot combine with either of these. Okay, so let's think about this. This is saying x cubed plus 7x cubed. Okay, and again, it's not showing it, but this would be like saying 1x cubed. So when I add these, I would think 1x cubed plus 7x cubed to give me 8x cubed. Okay, again, not combining the exponents at all, just the numbers out in front. Okay, and then again, this minus 4x squared cannot combine with that because it doesn't have a 3 exponent. So that's as much as I can combine in that group. Okay, so that's the idea. Okay, that's what we're thinking as we do these. Okay, now we were just kind of combining within one group or one polynomial here. Okay, for these, we notice we have a lot bigger of groups and a lot more terms to worry about. So yeah, we're gonna have to do a lot of these checks kind of as we do these problems, okay? But it gets faster. As you do these, right, it gets a little bit faster, okay? Something you can do as well that I've seen is you can kind of like circle or pair together your like terms first. Like circle the ones in the same color. Like if you have more than one color pen or something, you can kind of circle those. Okay, so if we look at this first one, let's just break down what this is saying. Okay, this is saying 2x squared plus 9x plus 4. So that's one group. And within that one group, this is going to be true for all these. Within this one group, there's nothing I can combine kind of within that to make just this group smaller. Okay, because again, these two have x's, but they both aren't x squareds, right? And this one doesn't have anything at all. So we would call this number without any variable at all to it. You're going to hear me call this a constant. It's kind of the opposite of a variable. Constant meaning it's a number that cannot change, whereas like a variable is a number that can change, right? So that's what that number is without a variable. Okay then, so when I look at number one, what it's saying is I'm adding this group plus this group. So I'm kind of going to combine these two groups into one single group, okay? And to do that, I need to look in these groups and I need to find, okay, which terms are like terms that I can combine across the two groups. And so first off, I have this 2x squared, okay? Now again, I said there's no other x squared terms in this first group, but in the second group, I look, and I have one right here, right? 7x squared. So I could say 2x squared, right? And the operation that I'm doing between these is right in the middle. That's telling me whether I'm adding the terms or subtracting the terms, okay? So the math that I'm doing is 2x squared plus 7x squared. Again, just like over here, I know that when I just add the coefficients, 2x squared plus 7x squared gives me 9x squared, okay? So that's what I get when I combine those two, okay? And then I look again, so I combine those, and it's something that's helpful too, as you add something from your original groups, you can kind of cross it out, because once it's combined, you're kind of done with it, okay? Now the second one, right? Positive 9x plus negative 4x. Now notice what I did there. The sign that's right before the term tells you whether it's positive or negative, as well as kind of saying adding and subtracting. So this is positive 9x, and this is negative 4x. So the math that I'm doing here is I'm going to add positive 9 plus negative 4, all right? Or kind of writing that small. 9x plus negative 4x. Okay, that's the math that I'm doing there. Okay. Or again, plus negative 4 is another way of saying like minus. Okay, so 9x minus 4x. Either way you do it, you end up with a positive 5x. So again, notice these pluses in here and minuses, they kind of serve two purposes. It's kind of telling you like what operation is happening, right? It's kind of saying 9x squared plus 5x. But it's also telling you whether that term that's right after the sign is positive or negative. So those signs kind of serve two purposes, okay? Now that takes some getting used to, but okay, now the last ones here, these constants. Okay, so I have this positive 4, right? Positive 4 plus negative 11. Okay, so positive 4 plus negative 11. Again, how I would write that, I could say 4 plus negative 11. Or again, that mathematically that's the same as 4 minus 11. Either way you write it is fine. But if I did that, 4 minus 11, I would get negative 7 as an answer. And that would be it. Once I combine all my terms that I can, and I don't have any left over, and I write it as a group, I'm done. Okay, so that's my answer right here. 9x squared plus 5x minus 7. Okay, so that is my adding the polynomials across, or adding those two polynomials together, combining them to form just one group, okay? Now let's try one more adding one, and then we're gonna do two subtracting ones, and then we're done. So number 2 says 9x cubed plus, or sorry, 9x cubed minus x squared plus 10 plus 14x squared minus 3x plus 5. Okay, so again, first thing to observe is what operation is happening between the groups, and again, that's plus, okay? Now again, I like to start with this group on the left and say, okay, 9x cubed. Just circle your first term and think, okay, is there any other terms that have a 3 exponent, right? Because again, you can kind of look, all your variables are x's, so we know that for this one. But so mainly I want to look to see, okay, any other 3 exponents in here? And there's not, right? There's no other 3 exponents, which means that, kind of in my group, there's nothing for this to combine with. It's like 9x cubed plus nothing. So 9x cubed plus nothing would still be 9x cubed, or 9x to the third power. Okay, and that happens sometimes. Sometimes there's just not like terms with everything, so you just pretty much keep it the same. Okay, and then for my next term, negative x squared. And again, what's helpful here is if you say negative 1x squared, right, to remind you that this is negative 1. That's how many there are. So negative 1x squared plus 14x squared. And there's no sign in front of this one, so you might be thinking, is that positive or negative? And if it's at the very beginning and it doesn't have a sign, it's positive. Okay, if it was negative, it would have the negative sign in front of it. Okay, kind of like this one down here, you can see. Okay, so this is negative 1 plus 14. That's the math we're doing. So negative 1x squared plus 14x squared gives me positive 13x squared. So that's what I get when I add or combine those two. And again, I haven't been doing it, but again, you can, once you use those terms or kind of write them in your final group, you can cross them out. That can be helpful because looking at these big lists can be overwhelming sometimes. Okay. Now my next term here in this group is a 10, but when I look at all my terms, right? When I look at all my terms, this negative 3x is here, and that's my last term that has an x with it, right? The other two are constants, right? These numbers without the x. So this negative 3x, I look at that, and there's no other x's there, like I said. So that means that this, just like the 9x cubed, this negative 3x is going to come down as well and not be able to combine with anything from the other group, okay? So that's helpful to notice too, okay? Because there's something about the order that you want to write your answers in. I'll say that in a second, but let's first combine my last two numbers here, right? So positive 10 plus positive 5, right? Both pluses in front of there. So 10 plus 5 gives me positive 15. And that's my answer. That's my whole answer right there. I've combined everything, and there we go. Okay, but like I said, there's an order. There's an order that you're supposed to write these in, okay? And I've been doing it kind of subconsciously because you just get so used to doing it. But notice the order, right? The order that you'd write your answer in, and this is kind of the official way to write polynomials, is when you have all these different exponents, the right order to do it in is you write your it's not just your highest number overall first, which is what you might think, right? Because like 15 then would come first because that's the highest overall number, and then 13 and then 9. But it's the highest exponent that determines the order. Okay, so the 3 is the highest exponent, and then 2, and then it's not showing it here, but this would be x to the first, and then this doesn't have an x. Or you could say this is x to the 0 power, but again, you never see that. But so the highest exponent is how you'd write the order here. And it was the same with this one: 2, x to the first, 1, and then no variable. Okay. So again, that's not as big of a deal as you're first learning it. Don't worry about it. But if you wanted to write your answer in the official order, that's how you would do it. Okay. All right. So 2 more. We're going to get into some subtraction. You notice that these are minus signs in the middle here. Okay. So that's telling me that I'm subtracting these. Okay. So let's look at that. Okay. So with this one, again, I can kind of go through the same process and think, okay, 8x squared. 8x squared. And then I look at my other term, that's not an x squared. In this group, my first term here is an x squared. Okay, but you got to be careful here because it can be super easy, right? Especially if you're doing like a mixture of addition and subtraction problems kind of at the same time like these. It can be so easy to just say 8x squared plus 7x squared is 15x squared and just write it. Okay, but you're subtracting. So it's really important that you notice what operation is between the two groups before you jump in, okay? So because this is a minus, I have to think, okay, the math I'm doing is 8 minus 7, right? I didn't write my x squareds, but I'm really just combining the coefficients. So 8 minus 7 would be 1x squared, right? Because I'm subtracting, okay? So that's what I would write when I combine these two. 8x squared minus 7x squared is 1x squared. Okay, and I use those. Okay. Now it gets really tricky when you have a lot of negatives involved in the groups as well. Okay, so look at this. what would I say this is? This is negative 1x, okay? So negative 1x minus negative 13x. So that's crazy, right? Look at all those negatives. Negative 1x, let me just write that. Negative 1x minus negative 13x. Again, that sign is saying that this 13 is negative. But yeah, negative 1x minus negative 13x. Now this is weird. This is a weird rule with math, but you might have learned this before. When we have minus a negative, I'll write that bigger up here. So when we have minus a negative, that's what this is saying, is negative 1x minus negative 13x. You might remember this rule, but when we have minus a negative, that mathematically is the same as saying negative 1x plus 13x. It's super weird, okay? But subtracting a negative thing is the same as adding the thing, okay? So what I like to tell my kids, when you see these two negatives like right next to each other like this, okay, you can kind of combine those to make it a big plus, okay? Because that's what ends up happening. That's what's mathematically the same. And if you don't believe me and you're like, oh, that's weird, do that in your calculator. Do like 1 minus negative 13 and then do 1 plus 13. You'll get the same answer, okay? So that's the math that's happening here. Negative 1x minus negative 13x or negative 1x plus 13x. Either way, you get positive 12x when you combine those, okay? Again, that's weird, but that's what's there, okay? Now, an extra weird thing that's going to happen here, okay? I have right, I'm subtracting. In this second group, I have this positive 27, okay? Now, you might think, oh, 27 doesn't have anything to combine with, so I'll just write that down there, right? But you're able to do that with addition, okay? When it's addition, because you're just adding the two things, you don't really have to worry about signs as much. So you just bring down whatever, right? Like I was able to do that with this negative 3x. I just brought it right down. I was fine, okay? But with this thing, okay, think about this. What you're doing technically, mathematically, even though there's not a constant number in this group, okay, even though there's not a constant in this group, I'm still doing some, like this 27 is being subtracted from this group, okay? Even though there's not like a constant number in here, what I could say is, I could say, right, if the, like you could just as easily like make this first group 8x squared minus 1x plus 0, right? Couldn't you just like say that that's there even though it's not written? Plus 0 like doesn't change it. So like I could say that that's there. But so technically, mathematically, what I'm doing is I'm doing 0 minus positive 27, right? Even though it's not written there, there's like, that's kind of like a placeholder for me. They're saying, okay, 0 constant, so 0 minus 27. And this is why I'm kind of stressing this so much. Because when you subtract it and it's in the second group, 0 minus 27 would be negative 27, right? So in my final answer group, I'm going to write negative 27. Because if you would have just like brought down positive 27, you would have written plus 27, and that'd be incorrect, right? So you got to have to think a little bit about this negative in here and how that's going to affect it, right? If you don't have. Now I'm going to show you a little trick with that, how you can make that a little bit easier. It just takes one extra step kind of at the beginning. It requires you to do one extra thing at the beginning, and then you won't ever deal with these messy like sign problems, okay? So I'll show that for number 4, and then we'll be done. But yeah, that's the whole thing there for number 3. So hopefully that makes sense. But okay, now here's my trick, okay? Looking at number 4, when we have this group, and again, this one's being subtracted as well. So when we have this big group, okay, what we have, again, what this is saying is this whole first group minus this whole second group, okay? So I have to account for the fact that I'm like subtracting every single term in here from every single term here, okay? So here's what I can do. This is my trick. I call it distribute the negative, okay? You guys know distributing like multiplication, right? You kind of multiply it by everything in the group, okay? Distributing the negative is kind of the same thing, okay? So watch what I'm going to do. I'm going to kind of give this negative sign, this subtraction sign, to every term in this group, okay? And what distributing the negative does is it changes the sign of each term in that second group. So look what's going to be left now after I do that. I'm going to have, right, it's changing the sign. It's making it the opposite. So if it's a negative in here, it's going to become a positive. If it's a positive in here, it's going to become a negative. Okay, so I would have, I'm just going to change it. So it was negative 2x cubed in here. It's going to become positive 2x cubed. Negative distributed to this. Negative 1x squared becomes positive 1x squared. Positive 6x becomes negative 6x. And then positive 19 becomes negative 19. Again, that's what would happen. Like if I subtracted these, that's what would happen. I would do, like minusing a 19 is the same as just writing minus 19. Minusing a negative 2x, like I said up here before, minusing a negative 2x would be the same as plus 2x or adding 2x. So that's what distributing the negative does. It kind of helps you to account for the fact that you're subtracting every term in that second group, okay, beforehand, so that you don't have to make any sign mistakes or have to worry about any of that, okay? So it's an extra first step. And you only do that to the second group, okay? The first group's kind of there, and you don't have to worry about the signs as much for that one, okay? So what you can do here in this extra step is just bring this first group down exactly how it was, okay? So for this first group, it's going to be 5x to the fourth plus 3x cubed minus x squared plus 9, and then your second group, okay? And what's nice about this too, I know the parentheses often trip kids up. Now you dropped off your parentheses, and now it's just one big group, one big polynomial, and now you can just worry about the like terms and combine those, okay? So just real quickly, let me just finish this one out, and then we'll be all done, okay? So again, you look at this, 5x to the fourth, okay, 4 exponent, right? You look through your whole list here. Do any other terms have a 4 exponent? No, right? So I can just write this as 5x to the fourth. Okay, that doesn't change. Okay, now my next term is 3x cubed. Is there another x cubed term in here? Right here, right? There's my 3 exponent right there. So what I have is 3x cubed plus 2x cubed gives me positive 5x cubed. Okay? So that's that one. Next, I have this negative 1x squared. So negative 1x squared, again, I keep looking through. Here's another one, right? Positive 1x, sorry, yeah, negative 1x squared plus 1x squared. What's going to happen there? Negative 1 plus 1 would be 0, right? So these guys would cancel each other out. You could write plus 0x squared in your final list, but that really doesn't mean anything. Okay, so those terms kind of cancel each other out. So there's no x squared term in there. Okay, and then again, I keep looking through. If I want to stick with my correct order, right, I dealt with my 2 exponents. Now I look and see, okay, is there any 1 exponent in here? Right, that doesn't have an x, so I can kind of skip by that for now. And then this guy, right, negative 6x, right, doesn't have anything to combine with, so I just bring that down, negative 6x, okay. And then lastly, I have my two constants, right? I have positive 9 minus 19, so 9 minus 19 gives me a negative 10. So there it is. There's my whole big problem all solved out right there, okay. So guys, I hope that makes sense. Just solving adding and subtracting a whole bunch of polynomials. I know it's a lot, but I hope it makes sense. Mathematically, it's actually not too tricky, but there are some little rules and stuff to worry about. So hope it makes sense. Guys, thanks for following.